Hey guys, so let's go through chapter 1.2, which is going to be the acid base of amino acids. So the key idea for this chapter is amino acids are antiphoric or antipathic or whatever your teacher calls it, meaning they can act as both an acid and a base. Okay, so meaning that they can donate and accept protons. So every amino acid has at least two pKa values, right? And the amino acid can have, no, we'll get into that. So either your pK1, you always have 2.18, or they say roughly 2, and then your pK2, you always have that, right? Because we know the general structure of one of these acids is you always have an amine and you always have a carboxylic acid group. So, but some art groups have an additional pKa that we'll call pK3, and those are going to be your groups here, your charge side chains. So these guys are going to be your negative side chains, and these guys are going to be your positive. Main thing is all of these guys have pKa values, so now you're going to have 3 different values instead of just 2. So now you're going to have 3 different pKas. You're going to have this guy, this guy, this guy. You're going to have this guy, this guy, that guy. And again, we can keep going. For all of these charged ones, you're going to have 3. Okay? So when you have an acidic environment, that means that you have a high H+, all groups are protonated, okay? So that means that your amine group would be NH3+, and then your carboxylic acid group will be COOH, and then your net charge would be +1. And this is with an amino acid that only has that only has the 2 pKs. So if we have we're going to draw aniline. Okay. So for this one, let's say that low pH, we're going to say like really low. Like under this, right? It needs to be under that. So I know a pH of 1.5, right? So because we're in this pH of 1.5, we will have this group here, okay? Your charge would be +1. But again, if this was an R group that has a pKa, then everything would change. Not everything, but your charge of the molecule can change, and then, you have a slightly different molecule. So when your pH equals your pKa, it means that half is protonated and half is deprotonated, okay? So it's sort of like a 50-50 of each, and this is one way that we form buffers. So when you're in a basic environment, that means that you don't have a lot of H+, so it would look like this. And again, we're going to use aniline again. Okay, so you see the difference between those two, and again, all that changed was the pH. And then if we're at physiological pH, it would be... Now, this is the state that will be at the most. Again, we're just going to use aniline again. And this net charge is going to be 0. So as you can see here, we can have 3 different forms of amino acids. So, titration curve. So, every time that, for each pKa, you're going to see sort of like a bump. Like here, if we were on a curve, I would say, okay, this amino acid only has 2 pKas because there's only 2, right? And then if I do this, okay, this amino acid now has 3 pKas. So, So your vertical region would look something like this, okay? So you'll have like this and this. And that would be your equivalent point right in the middle. So that's when, again, occurs when full proton is lost from a group. So that's your buffering. That's your vertical region. So your PI is pH in which your amino acid is neutral. So it's going to be in that form, this form here. Okay, that's the only state where your amino acid is neutral when you have a non-charged amino acid. So yeah, again, so like here for sorry, this came up weird, but it should be pKa 1 plus pKa 2 over 2. And that would equal your pi. Okay. And then for charge, it changes a little. So if the group is acidic, your pi is going to be low. If the group is basic, your pi is going to be high. And then this is the difference between your acidic amino acids and your basics. So pretty much, instead of using the pKa of just like anything, for acidic, you would have to use the pKa of your carboxylic acid group, and then for basic, you would have to use the pKa for your amines. So I'm gonna start doing this at the end of videos. So we're gonna go over some like MCAT strategy tips. So I would definitely say, definitely big to know how to identify pi from a titration curve. Obviously, you should know the net charge of any amino acid at any pH, and you should know how to draw the structure of an amino acid at both low, neutral, and high pH. Okay, I'll put this on the screen one more time for anyone. Please, guys, you do need to know. Except for these guys, and again, these guys are for the sweats. Like, if you want a 528, go ahead and put that on your card. But other than that, you don't need to know that shit. All right, guys. So, see you next time. Let's go. Let's keep going.